Power supplies usually incorporate circuitry that inhibits the operation of the power supply if the input supply voltage is too low or too high. Low input voltages are stressful to a power supply because the input current rises as the input voltage drops. Most AC power supplies have a lower input voltage limit to prevent overheating of the internal components. Excessively low input voltages can cause faulty operation of the control circuitry and insufficient gate drive voltage to the MOSFETs and the IGBTs. High input voltages can damage transistors and other components as their voltage ratings are exceeded. Be wary of switching generated transients, which a high input voltage condition may exceed the transistor specifications. When the input voltage to a power supply is out of specification, the safest response is to turn off the power supply until input conditions improve. Overvoltage circuits provide protection for the load in the event of failure of the power supply. A crowbar circuit typically includes a silicon-controlled rectifier, SCR, a fuse, and a voltage sensing circuit. If an overvoltage is detected, the SCR is turned on to a conducting state, and the current from the power supply flows through the fuse and the SCR into the power return line, the ground line. The fuse is sized to blow at the maximum current rating for the power supply, but not at the normal current load experienced by a functional system. Fuse tolerances are quite wide, so the power supply must be rated for more current than the required by the load to ensure that the fuse will blow when the crowbar is activated. The cost of providing a crowbar circuit and associated cost of a power supply with a higher current rating load must be weighed against the cost of destroying the load if a power supply failure occurs. There are four basic behaviors a power supply can provide in response to an overcurrent situation. 1. The power supply can immediately shut down and then periodically check to see if power can be restored. This is the auto restart function. 2. The power supply can tolerate the overload for a period of time before it shuts down, perhaps a few minutes. This is thermally limited. 3. The power supply can enter a current limited mode. The full rated current is delivered to the load. The output voltage is determined by the load current and the impedance of the load. An issue with this response methodology is that the power supply is providing high power to a load that may have experienced a failure. This could become a fire hazard. 4. The power supply enters a power limited mode. The output voltage is reduced but controlled as the output current grows. The goal is to limit thermal overload. This mode is useful where the load can tolerate a voltage drop.